Okay, so looking at multiplication and division for 3-digit, 2-digit numbers and some avoiding decimals, we've got a page of examples to work through here. First of all, this is the Chinese grid method. I've already drawn the grid up with 321 across the top, 47 down the side. This grid can be varied in size depending on how many digits your numbers have. For example, the one underneath is a 2 by 2 for 6.2 multiplied by 1.7. You complete the grid thinking about the single digit multiplication. So in any order you wish, the top row there, 1 multiplied by 4 is 4, 0, 4, 2 4s are 8, 0, 8, 3 4s are 12, 1, 2. The triangle split the numbers into tens and units. So anytime you don't have a 10, put a 0 in just to make sure that you haven't left a digit out. 2 7s are 14, and the last one, 3 7s are 21. When you've completed the multiplication, you start addition across the diagonal from this bottom corner here. So the first diagonal will just be the number 7. The second diagonal will be the 4 0 4. The third diagonal will be the 1 1 8 0. That makes 10. So note down, carry 1. We've got 0 2 2 1. Don't forget the number you've just carried. That makes 5. And then our last diagonal is just 1. So the answer to our question, 321 multiplied by 47, is actually 15,087. The method for multiplication of decimal numbers would be exactly the same in the grid. But once we'd completed the grid, at the very last point, we would make an adjustment for it to be a decimal answer, looking at the decimal places being used in the question. So 0 times 2 would be where I'd start. 1 times 2 is where I'd start. 1 2 is 2. 1 6 is 6. 2 7s are 14. 6 7s are 42. Once you've completed the multiplication, starting from here in this bottom corner, you add along a diagonal. First diagonal would be with 4. Second diagonal would be with 5. Third diagonal, 10. So 0 down. Carry 1. Third diagonal, just 1. So the answer to 6.2 multiplied by 1.7 has the digits 1054. Then when we look at the actual numbers themselves, we have 2 decimal places at work in the question, meaning starting from this end here, we count in 2 decimal places to place our decimal point, and the answer would be 10.54. For single digit multiplication involving decimal numbers, we treat the numbers as if they are just the tens and units, e.g. 3 5s would be 15. We then have a look to see how many decimal places are being used in the question. There's 2 of them. This tells me I'll have 2 decimal places in the answer, and the answer is actually 0.15. Similarly, 4 9s are 36. There's 1 decimal place in the question. There will be 1 in the answer, 3.6. We'd expect students to do this mental maths. 7 8s are 56. There are 2 decimal places at work in the question, 2 in our answer. 5 12s are 60. 1 decimal place in the question, so 1 in the answer. 3 3s are 9. 2 in the question, 2 in the answer. That time I was required to put my own 0 in to keep to the rule of having the 2 decimal places. And the last one, 5 6s are 30. 1 in the question, so 1 in the answer. So the answer is actually 3.0 or just 3. Looking at the division, before we move on to division, looking at the most efficient way of doing long multiplication, which you could use with Year 9, especially top set group. Using the long multiplication algorithm, the setup doesn't require a grid, but 2 lines for each part of the multiplication, and then the total being found from adding those 2 lines together. So starting by focusing on the 5, multiplying the row above, 5 5s are 25, 5 down, carry 2, 5 7s are 35, and 2 makes 37, 7 down, carry 3, 2 5s are 10, and that 3 makes 13. The top row is 1 3 7 5. To start the row underneath, we add a 0, as we are now going to be multiplying by 40. So 0 down, and we can multiply throughout by 4. 4 5s are 20, 0 down, carry 2. 4 7s are 28, and 2 makes 30, 0 down, carry 3. 2 4s are 8, and that 3 makes 11. When all the multiplication has been completed, similar to the Chinese box method, the final answer comes from addition. So 5 plus 0, 5, 7, 3, 2, and 1. The final answer will be 12,375. You must be aware of your place value when you're doing your addition so that you can see which column each digit belongs to for neat addition. Now moving on to division. I've got mental and maths division here written as fractions. Students need to be aware that a fraction, 5 divided by 0.5, is not 2.5, but how many 0.5s are there in 5? 0.5 is the divider. So as a bus shelter, this would look like that. But generally, if we're going to do mental maths division with a decimal, we would multiply top and bottom by 10 to get rid of those decimal places, and then consider how many 5s in 50. Multiplying top and bottom by 10 moves the place values 1 space over, making 30 and 2. How many 2s in 30 is easier to deal with. So similarly, you'd encourage them to think about 7 becoming 70 divided by 1. And over time, the students would become more confident in being able to do this mental maths. 0.2 goes into a whole one 5 times. 0.2 would go into 5 whole ones 25 times. 50 divided by 2, 25. Bus shelter method is used when you can't use a calculator for division. Bus shelter method requires you to work through division by 12 in a step-by-step basis. You start with the hundreds, if that's your largest digit, and you carry your remainders as you go across. How many 12s in 5? None. No 12s and nothing. Put that on the answer line. Carry the 5. 50. How many 12s in 50? 4. 4 12s are 48. I have 50, so there's 2 left over. How many 12s in 24? 2. 2 12s are 24. No remainder. How many 6s in 9? 1. 1 6 is 6. I have 3 left over. How many 6s in 32? 5. 5 6s are 30. So I've got 2 left over. How many 6s in 24? 4. No remainder. This question has a decimal place, but like the multiplication, I make that adjustment at the very end. If there's 1 decimal place in the question, there should be 1 decimal place in the answer. 7 goes into 1 0 times, 1 left over. 7 into 13 goes once with 6 left over. 7 divides into 60 8 times. 7/8 of 56, so there's 4 left over. 7 goes into 49 7 times. 18.